welcome back to Insects for Fun, the podcast where we dive into the weirdest, wildest, and most wonderful corners of the insect world. Today, we're turning up the heat, literally. We're exploring the steaming, bubbling, and sometimes downright scalding habitats of insects. From geysers in Yellowstone to the volcanic slopes of Japan, let's meet the bugs that like it hot. Our first hot spring hero is a tiny but tough midge from the family Chironomidae, also known as non-biting midges. You might remember that the only insect to live in Antarctica was also a midge from this family, so it seems like these insects just know how to survive in the worst places imaginable. Today's midge is Polypodilum vanderplanki, a species known for its extreme dehydration tolerance. While not exclusively a thermal insect, some midge larvae from this family have been found in warm to hot spring environments. In Yellowstone National Park, several chironomid species inhabit the edges of hot springs where temperatures can range from 40°C to 50°C, which is 104 to 122 Fahrenheit. These larvae stay just within the range where enzymes can function and oxygen levels remain viable. They also build little tubes or burrows in the sediment to protect themselves from sudden temperature shifts. To survive the heat, these midges rely on heat shock proteins, which stabilize their cellular machinery under thermal stress. They also feed on thermophilic algae and microbial biofilms, which thrive in the nutrient-rich hot spring environment. The next insect is one of the most famous hot spring insects, known as the Cascade stonefly, Zapata glacier. Although technically a cold-adapted species, other stoneflies in this family, Nemuridae, have been found living near hot spring-fed streams. These stoneflies often hang out in thermal outflow zones, where warm water from a spring meets cooler stream water, creating a temperature gradient. The ones that thrive here have specialized adaptations for not overheating, such as increasing the production of enzymes that don't shut down at higher temperatures. Their gills are also efficient at extracting oxygen in warmer, less oxygenated water. As for what these larvae eat, they're primarily detritivores, or scrapers, feeding on decaying plant material and algae growing along submerged rocks in these warm waters. Now let's meet some aquatic daredevils, diving beetles in the family Dytiscidae. Certain species, like Hydroporus thermalis, have been found in hot springs from both Europe and North America. These beetles can tolerate water temperatures as high as 45°C, which is 113 Fahrenheit. They do it by trapping air under their elytra, creating a sort of scuba tank that lets them breathe even when oxygen levels are low. Some also have behavioral thermoregulation, like swimming deeper during hotter periods of the day. Both adult beetles and larvae are predators, hunting small aquatic invertebrates. The heat really doesn't seem to slow them down one bit. Here's a fun tidbit. In Scandinavian folklore, diving beetles were once believed to be guardians of enchanted springs. Their shiny bodies were said to reflect the soul of the spring itself. Next on our list would be the thermophilic caddisflies, which are moth-like flies with aquatic larval stages. In Yellowstone and Japan, several species of microcaddisflies from the family Hydroptylidae have been recorded in warm water environments. These tiny aquatic insects build protective cases and graze on thermophilic algae and bacteria. Their diet of biofilms and microbial mats actually provide both food and protection from fluctuating temperatures. Some species, from the genus Ochrotrichia, are especially heat tolerant and can be found right at the edges of boiling thermal pools. Their cases are often made from silica-rich particles found in the thermal sediment. To survive the intense heat, these insects produce specialized heat-stable enzymes and also have protective proteins similar to those found in thermophilic microbes. Second to last, we have hot spring springtails. Technically, springtails are not true insects, but they do deserve a shout out here and will be getting their own full episode in the future. Now, some species of springtails, like those in the genus Falsomia, have been found in geothermal areas, living in warm, moist soil near steam vents. They survive thanks to a mix of water-retentive cuticles, antifreeze-like proteins, and even heat shock proteins. These help stabilize their cells and prevent dehydration or heat-induced damage. As for what they eat, well, they feed on fungal hyphae, which are kind of like roots, but specifically for fungi. They also feed on decaying organic matter and thermophilic mosses, making them key players in nutrient cycling, even in these toasty zones. Last but definitely not least, we have lava crickets. These special crickets belong to the family Grylidae, also known as true crickets, and are often found on volcanic slopes in regions like Hawaii. Lava crickets are actually the first ones to arrive after a volcano erupts, and prefer the barren, newly hardened surface of dried lava. They survive by eating decayed plant material blown by the wind and drinking sea foam, which apparently has proteins similar to those found in egg whites. In fact, once plant life starts budding out of the dried lava, these insects lose interest and move on to pioneer the next barren wasteland. What's stranger still is that these crickets are by all accounts not built for success. They have no wings, can't sing, and only live on barren lava flows. They also have this really weird mating ritual where females bite the legs of males and drink up to 8% of the male's body mass. They're also highly elusive, and efforts to catch and study them have largely been unsuccessful. That being said, local Hawaiians to the Big Island of Hawaii have long known about these insects and have given them the name Uhili Nene Pele. Uhini refers to them as a grasshopper-like insect, and Pele is the goddess of fire. As for Nene, I honestly have no idea because that's also the name given to an endemic goose. And with that, we're gonna wrap up today's episode of Insects for Fun. Be sure to follow for more arthropod and insect facts, and if you want to support the show and check out vlogs of my insect rearing and blacklighting adventures, or bonus episodes covering a wide variety of news in the world of insects, then check out the Patreon. A huge thank you goes to our newest patrons, Tiger and Melissa, for their support, and of course, a great many thanks to all my patrons for helping keep this afloat. And you'll hear from me again next week.